Hi, in this video we are going to discuss what is link budget and how the link budget is used to calculate the path loss. Okay, so I think everyone knows what is this image, isn't it? It's nothing but a link and this is a budget. Okay, so it is called as a link budget. It's a simple thing to guess the topic. Okay, so everyone understands the word budget. So what is budget? Normally for anything, even from a home and up to the our total nation, we are having a budget, isn't it? So budget is nothing but we are calculating the total income and total expenses, isn't it? And what is the bitfall in between the income and the expenses? The same process we are doing with the communication link design also. What is communication link? It is nothing but a physical link or a wireless link which connects your transmitter to the receiver for transmission of signals. That is called as a communication link. So before calculating the budget, we should know the characteristics of the link. What is the type of the link, whether it is wired or a wireless, and what is the path it followed, either a line of sight alone or it may have some losses, and what kind of the losses it might occur in between. So like that we have to study the characteristics of the link, and after that based on the characteristics we are calculating the path loss. Depends on the value of a path loss, we are going to calculate the required received path. So the link budget is mainly used to predict the performance of the link before it is getting to be established. Okay, because we have to show in advance if it will be acceptable one or not. And so if one option is better than another, so we can analyze what type of the link we could establish so that it will give the good results. And also it provide a criterion to evaluate the actual performance. So this is the free space path loss. Between a distance and path loss we plot. When a distance increases, path loss also get increases, isn't it? So this is the actual model we consider for calculating the power in wireless system. It's your transmitting radio and your receiver radio. Both of them are connected with an antenna, transmitting antenna as well as the receiving antenna by means of some cables. Okay, this is your transmission path. It may be a wired or a wireless. Here in the case we consider only the wireless. Okay. Now with the transmission power, okay, coming out from your transmitter, and due to this cable there might be some loss occurred. So gain are indicated by the green color, whereas the losses are occurred by the red color. Okay. So by means of using an antenna, there might an increase in the power, and due to the wireless medium, there may be a path loss. The gain antenna, there may be some gain, and due to this cable, there might be some loss. Finally, here at a receiver, we are calculating the margin using a receiver sensitivity. So the performance of any communication link depends on the quality of the equipment that is being used for the communication system. So the link budget is quantifying the analysis of a link performance. There might be a different kind of losses like noise, fading effects and interference. So this is your path loss downlink and this shows your path loss uplink. So we are calculating the difference between the minimum received signal level and the actual received power, which is called as a link margin. Link margin is always a positive value and we try to maximize it, will give the better results. See here you have a transmitter and a receiver. A number of connectors may exist in between the transmitter to the receiver. Say here the distance between your transmitter to the receiver is 1 kilometer. So here a total system power budget is considered to be 14 dB suppose, then actual received power due to this link loss may be 2.5 dB. So the link margin we have to set over here is 12.5 dB. So we are transmitting 14 dB. Instead of that, we are getting only 2.5 dB because of there is 12.5 dB losses occurred in the link. So this is a typical example, shows how the loss will get occurred. Okay. Here is another example for the better understanding. See here we are starting from plus 12 dBm transmission power. Due to cable there is a loss of 2 dB. So we indicate with a minus sign. And antenna there is an addition. Gain occurs that indicated by the plus sign. And path loss, for every 5 kilometer it occurs as minus 114 dB, and due to antenna there is another gain of plus 14, and at the receiver cable we have a loss of minus 2 dB. So with that we are going to calculate the power received at your receiver side. So we start right from the transmitted power. So transmitting power is 20. Antenna gain, that is transmitting antenna gain, is plus 10. So it is gain, we are indicated with plus sign, and loss indicated by the negative sign, subtraction. Okay, so cable loss 2 dB, and antenna gain, client side you have another plus 14, and client side you have a cable losses of minus 2 dB. So by adding all these values we will get a 40 dB total gain at your receiver. But we have a free space loss at 5 kilometer is minus 114 dB, isn't it? So the expected received signal level is 40 minus 1114, so it is equivalent to minus 74 dBm. But minus 82 dBm is the sensitivity of the client. So by fixing this value, what we are doing, we are fixing the link margin to be 8 dB. So we will attain this sensitivity of the client at your receiving side. So this is the way we are fixing the link budget. So this link budget makes a log by keeping all entries of losses and gains in a single signal propagation. A wave is attenuated via amplifiers and by means of an antennas to increase the gain product and also try to eliminate the noise. And data may be lost during the propagation of a signal between your transmitter to the receiver within one device or between two or more devices. So by keeping track of such losses and gains, it is important to calculate the reliability and efficiency of the link. So with that we close this video. You might have get some idea about what is link budget. Okay, so kindly take this assessment for a better understanding. Thank you.